Record to the cloud. Great. Share. Oh, this is how I do it. This is how I do it. Oh. Yeah. Shoot. It's this darn dongle. Okay. Is it gonna work? The one part I couldn't test yesterday. Okay. Nothing, huh? Oh. That's annoying. Because I'll need to do it with my laptop then. Crud. Okay. I went to talk to EdTech the other day, and they said, oh yeah, you can use whatever software you want. Did I tell you guys this? But there's not going to be any support for it. And I was like, well, there's not really any support for what I want to do now, so who cares? All right. Something tells me it's just going to be a blank screen, but let's roll with it. And if nothing else, you'll have the notes, the PDF of the notes, and the audio. Not ideal, but it's something. So, all right. Welcome. All right. So, what a disappointment. I'm so close. But walking up the stairs, I knew this dongle would be the death of me. Oh, well. We'll see. Okay. Are you ready or what? So I think I started and I said, oh, stats is so fun last day. I'm sure I said something like that. And then I didn't actually elaborate. What is it even? I think I might have said that, left it at that, left you guys wondering. So stats is, I don't know if you know, a lot of people think it's just like sports statistics. Those are stats, but the stats that we'll be doing is more analyses. Okay, so business analytics, for example, or market analytics, or any sort of analytics that's stats. So there's a lot of different components that we'll deal with. What's tough about this course is we touch on a lot of things, right, just to give you a little bit of exposure, and then we'll dive deep into just a few of those things, okay? Still very vague, still haven't told you what it is. So stats in general is where we want to know something about the population of spenders, for example, or population of website users, or the population, so any sort of population that you want to know something about. Manatees, you want to know something about manatees, right? My favorites. So we have some population that we want to know something about, right? Essentially a research question, okay? So then in stats, and it's all part of stats, we collect a sample, so just a a smaller section of that population. Okay, so part of our course is going to be dealing with, and not a huge part, but part of the course is going to be dealing with how do we collect that sample of the population. Right? And then once we have that sample, we can do calculations on that sample to try to learn something about the whole population again, right? Because most of the time it's impossible to collect information on the entire population, right? So we take this sample, and if it's done properly, then we can use information such as, let's say, the average, right? The average from the sample to learn something about what the average of the whole population might be, right? So, all right, there we go. It is, what's the date today? Oh, it's on here. I'm so used to writing the class and the date. All right. There. Oh, okay. It's all fun and games until Siri calls 911. What is statistics? What is it in general? Okay. It's when we use, let's call it what it is, data, right? So just information, we've collected data, right? I think we're all familiar on some level, right? So it's when we use data, okay, I'll put in brackets from a sample, okay, to learn something about a population. To learn something about a population. So when I first started taking stats, I had this guy named Jason, and he was my supervisor for my master's later, but he kept doing this, he kept drawing this, a big circle, and he said, okay, this is the population, and then a little circle, this is the sample. I was like, yeah, I get it. I get what a sample is. It wasn't until much later in the course that I was like, oh, from a sample to a population. Okay. So I'm just gonna do this little donut thing, leave it with you, right? But in general, let's say we want to know about the average height of a population, kind of a basic example, right? So we want to know the average height of males. Maybe let's narrow it down between some ages, right? Whatever, right? That's our population. We would take a sample of males that fit that category, right? That age category that we picked. And then we would calculate the sample average. And then that would be our best guess for what the population average might be. Okay? So we pick some population that we're interested in, we collect a sample, we do analyses on the sample, and then we try to learn something about the population. Okay? That's stats. There, we can all go home. Okay, so just so you know where we are, and sometimes I do forget to put it in the notes, but this would be considered section 1.2. What follows here? Okay. So, like I said, we're gonna have a sample average that we're gonna find, right? Calculate. And then we wanna learn something about the population average, right? Those are both averages. So just calling them the average wouldn't really make sense, right? So we need to develop a lot of terminology, right, around how do we talk about a sample versus a population, okay? So, we need to be able to distinguish whether information came from the population, right, or from a sample. Okay? So we need to be able to distinguish between, information from a population okay. Population being everyone or everything of interest. Okay. And information from a sample. Information from a sample, okay, which I'll put in brackets, would be a carefully selected subset of the population. Okay. So a carefully selected, welcome, subset, no worries, of the population. I've noticed that when I write, sometimes I forget words. It's pure laziness, or I just talk too fast or whatever. So if I forget a word in there, let me know. It's possible. I don't mind. Usually you can kind of figure out what's missing. Okay, so in general, like I said, we need to develop a lot of terminology, and that's what we're doing here in chapter 1 is we have to introduce all this terminology. Okay, it's going to be kind of boring, and what the tricky part about stats is depending on what discipline you're in, people like to use different terms for the same thing, so it's kind of my job to introduce them all to you, and then I'll say we're going to use this one, okay? But there's a lot of different terms, so it's going to feel like a lot, but once we get going, it'll be fine. Okay? So if you're dealing with a population, any sort of information about a population we call a parameter. Okay. I remember it because there's P and P. Right? So a parameter is information about the population. Okay. So it's a calculation. Technically, you could collect all the information in the population and calculate the average, for example, right? You just won't. Okay. So it's a calculation or any sort of number derived from an entire population. From an entire population. Okay. Whereas if you're dealing with a sample, that same value is, prepare to have your minds blown, called a statistic. And I remember S and S. Right. Sample, statistic, population, parameter. Okay? So a statistic is, again, any measurement or any calculation or number derived from a sample. Okay? So using the same wording as we did for a parameter, it would be a calculation or number derived from a sample. Okay. So at the very basic level, right, we're going to have a sample average that we talked about, and we're trying to use that sample average to learn something about the population average, right? So we spend a lot of time trying to do something with the averages. So that's kind of our main one, but we'll do some others too. Okay, so we use statistics in the sense of the term now, right? So we use statistics to learn about their corresponding parameter. Okay. So for example, two kind of main players are going to be the average and the standard deviation. But in stats, again, same terms, right? Average, we like to use the term mean. Okay? The mean is the average. Okay? So the most common term or common statistic or parameter, statistic or parameter we analyze is the mean. Should write that clearer. Not much better. Oh well. So the mean is just the average. Okay. Okay. And it's just going to be a measure of center, right? The average, I think we all recognize the average would be kind of a central, I don't know how else to say it, average value, right? I think we all just kind of intuitively understand that the average is a central value, right? So it's going to be a measure of center. There's lots of different kinds of measures of centers, but the one that we'll be most concerned with is the mean. Okay. We'll talk about some others, but at the end of the day, we only really care about the mean. Okay. So, for example, so if we have a sample and the population, remember the reason that we're kind of developing all this terminology is so we can differentiate between a sample average or a sample mean and a population mean, right? They're both the average or the mean, and so we need to kind of keep those straight. The mean and the standard deviation go hand in hand. Okay? We haven't talked about the standard deviation, but it's a measure of spread. Right? So the mean is the measure of center. Standard deviation is the measure of spread. Okay, but we'll come back to the standard deviation, but I want to throw it on there so it doesn't look like I have a one-row table. So we can talk about the mean, and we can talk about the standard deviation. Try to do kind of a table here. Okay. Because this is probably the hardest thing to grasp in this course. Okay. So the sample mean, right, is going to be denoted by x with a bar over it. We just call it x bar. Okay. Whereas the population mean, we're going to denote it with a Greek letter mu. Do you guys know Greek letter mu's? You've probably seen it. It's micro, okay? But it's just kind of this fancy m. Okay? Or if you want to write it in letters, you can just use mu. Okay. That'll get messy, so I'd get in the habit of just using the Greek letters. But who knows? If you don't like using them for whatever reason, they're pretty fun, especially mu. Okay, the sample standard deviation is going to be denoted by just the lowercase s. Does that look like an S? Maybe it does, maybe it doesn't. And whereas the population standard deviation is going to be a lowercase sigma. So a lowercase sigma is just an O with a tail on top. Okay. So this is a sigma. Lowercase sigma. Yeah, I'll try to redo it, but I'm afraid they're all going to look like that. How's that? Looks like a 5. That'd be pretty bad. Anyways, so lowercase s. Can't win. Hopefully you can make better notes in your notes. Okay. So in our example, right, we've collected a sample, we've calculated our x bar, and we use our x bar to learn something about mu, right? So that's the whole, we use sample information or statistics to learn something about their corresponding parameter, right? Because this here would be a statistic, and these guys here would be parameters. Right? Just kind of tying it all together. Okay. So in general, what you'll notice is, as a rule, parameters are denoted by Greek letters, right? So you can kind of pick those out from a crowd, whereas statistics are going to be using sort of normal letters, right? X bar isn't really normal, but go with it, right? So parameters will always be denoted by Greek letters. Okay. Whereas statistics will be denoted by quote, unquote, normal letters. Sorry. So, like I said, the mean is going to be our kind of our MVP, most valuable player, right? So anything with a bar over it is going to be a sample average, right? So we have X bar is kind of the default sample average notation. But if you have multiple variables, and we'll talk about variables in a sec, then anything with a bar over it is just the average of whatever is underneath, right? So X bar is really just the sample mean of X. Okay. Height bar is the sample mean of heights. So what's this? It's your average smiley face. Average smiley face. Right? Because the mean's the average. Here's a smiley face with a bar over it. Fun, right? Just your average smiley face. Yeah. You can steal that one, don't worry about it. Oh. Okay, so all these things, right? X's, heights, smiley faces, right? Those would all be information columns that we've collected in our data, right? Usually we collect data and put it in a spreadsheet. And I think we've all worked with some sort of spreadsheet at some point, right? So it's nice to be able to imagine just a spreadsheet. So each column in that spreadsheet would be a variable, okay? Mostly because it varies from line to line, right? Each line represents a student or a manatee or whatever, right? And so because there's little variations, right, we call them a variable, okay? So we need to be able to talk about data sets, okay? So we need to be able to talk about data sets. Okay. So usually data is stored in a spreadsheet. Okay. Of some sort. Usually data is stored in a spreadsheet. Okay. And each column represents a variable. Okay. And each column represents, can I squeeze it in there? A variable, okay? There's lots of different kinds of variables, right? And we need to be able to distinguish between them, okay? And so now we need to learn some variable terminology. Not that it varies. So we need to learn some variable terminology. So I'm gonna make like a quick tree diagram, just 2 branches, nothing crazy. Okay. In fact, there's tons of little branches that you could keep going to name and classify all these variables. I don't really see the point. We just need the kind of the bread and butter here. Okay, so any column in a spreadsheet is a variable. Okay, so they're all variables. Okay? And at the highest classification, they can either be qualitative or quantitative, right? Or categorical, numerical. Okay? I'm going to use the latter, but here's one of those situations where I need to show you all the terminology and we boil it down. Okay, so we've got on the one side categorical variables. Categorical. On the other side, we have numerical variables. Okay. Categorical variables can also, I'll just put it in brackets, can also be called qualitative. And numerical variables can also be called quantitative. I'm going to use the ones. Oh, let's do a little highlight here. I'm going to use these guys. Fun. Okay. If you want to use qualitative and quantitative, right? That's fine. I know what you're talking about as long as you know that I'm talking about the same things when I say categorical, numerical. We're fine. Okay. So I like categorical and numerical because I find that it does a better job explaining what they are. Categorical variables is any information that you collect that just put in categories, right? So hair color, for example, right? What else? It's all eye color, right? Any sort of categories that we can develop, and there's usually a finite set of categories, right? So things like heights wouldn't be considered categories. You could make them into categories, right? You're between 5 feet and 5'2", that puts you in one category, right? So from a numerical variable, we can develop categories, right? But from categories, we can't develop just numbers, right? So categorical data is just data that can be grouped into categories. Whereas numerical data is just any sort of measurement, right? Heights, weights, speeds, distances. All of these are pretty common things that we collect, right? And so those would all be numerical. So the majority of this course focuses on numerical data and numerical data analyses, right? But the categorical stuff is just as important. We just don't touch on it that much in this course. Okay. That'd be another course. Which one? I don't know. Probably 2:30. So a numerical variable is just any measured value. And as a quick kind of check, if it makes sense to talk about the average of something, then you're very, very, very likely dealing with a numerical variable, right? It doesn't make sense to talk about the average hair color, for example, right? So if you're struggling, then you can ask yourself, okay, does it make sense to talk about the average? If it does, right, then you've got a numerical variable on your hand. Okay. There are curveballs, like if I ask you what year you're in, right? I could put those into categories, right? Those, that would be a categorical variable, but just because there are numbers in there and we could calculate the average, it doesn't really make sense, right? So as a check, okay, if it makes sense to talk about the average of a variable, it is numerical. Oops. Okay. So that's just a quick check-in. Okay. So there are obvious cases where we don't want to mix these two up, right? If you're writing a report and all of a sudden you find yourself reporting the average of something that you shouldn't be averaging, right? Or putting stuff into categories that you should probably calculate the average of, right? And so it's important from the get-go that we are able to look at a spreadsheet or a data set and be able to say, oh, this one's categorical, this one's numerical, categorical, numerical, etc. Right? Because then we know how to deal with these things. Okay. Any questions so far? You guys are so good. Okay. Not good because you don't ask questions, but you all seem to be listening so far. So it's great. How about I throw another thing in the mix? Okay. So any variable, right? We already decided any variable is either categorical or numerical, but then also any variable can be classified as either a response or an explanatory variable. Okay. And so a response variable is going to depend on your research question, right? You've collected data, you have this data set, and you have some research question in mind, right? Our original example was, what's the average height of males, right? So that would be our research question. We wouldn't just go out and collect a proper sample of males and then just measure their heights and let them go. We'd probably collect things like their weight and their age, right? What else? I don't know. Ethnicity. I don't know if you're allowed to do that. Things like that, right? So all those, you would have more than one variable, right? But our main variable is the height, right? So that's what's going to be our response variable. These other variables that we've collected, those are just going to be explanatory variables. We've collected those to try to explain why this person is as tall as they are, right? Is it their age? Is it their weight? Is it whatever, right? And so that's why we have another kind of branch, right? Response variables or explanatory variables, okay? So a variable can be either a response variable Okay. I'm going to put in brackets, I won't use this terminology very much, but a response variable can also be called a dependent variable, right? Depending on what field you're in, they like to use dependent, but I'm going to stick with the response, but dependent variable. Or an explanatory variable. Which sometimes we call independent variable. Okay. So we have, data, okay, and a research question. A research question. Right. So for example, what is the average height of males? Okay. So then we would collect a data set, right? So male, we've got number 1, number 2, number 3. Let's just make a kind of a fake data set here. Okay. And we collect things like, well, our research question is about the height, right? So we should probably collect their height, right? So here, our first variable is their height. Okay. I guess, yeah, males in general, like I haven't specified, but usually you would want to narrow it down to something, right? So I guess technically here we're talking worldwide. Yeah, tough to get a sample representative of the world. So, but yeah, good question. Technically, yeah, the world. Okay. Actually, you're right. At Okanagan College. Yeah, it's a little bit easier to grasp, right? But you see how you have to narrow down the population that you're interested in, right? Because otherwise, yeah, technically we would be talking about all the males in the whole world. That's huge, right? So we would collect their height. What else would we collect? We would collect maybe, let's throw their hair color in there. What if we find that their hair color explains their height? Probably not. Age, good. Thanks. Probably their weight. And now I've run out of room, right? But we would collect all these things because not only do we want to know the average height, right? That's our research question, right? But we want to be able to talk about, okay, so people who weigh in this range, they are typically this tall, right? And then eventually you would have developed a model, right? That says that if you're, probably not your hair, you wouldn't be able to use your hair color probably, but what if your hair color is brown and you're 30 years old and you weigh, I don't know, 170 pounds, then we predict that your weight or your height would be this amount. Right? So that's kind of the whole goal, right? Is to collect these things and then eventually be able to predict new data. Right? So this one here, the height, let's say, I don't know, what are some heights? Let's call them 6 feet. How do you denote? I'm metric, but for some reason everyone talks in 1, 2. Nice, thanks. And let's do whatever, right? let's say brown, blonde, black, healthy mix. Okay. Age 21, 32, 27. Okay. And the weight, oh goodness, okay. 180. Is he really just tall and skinny, or what's going on here? I don't know. This poor 6'2". Male number 2 blows away in the breeze. All right, so we've got this kind of fake data set. These things keep going, right? And so the height, that's the one that we set out to learn something about, right? The average height. Okay, so that's going to be our response variable. All the rest here will be explanatory variables. Wait a second. But hair color is categorical, right? Weight, numerical. So that means that we can have, well, the height, let's talk about the response variable. The response variable is numerical, right? So that means that we have a numerical response variable. Okay. So this one would be, actually, let's do it like this. So the height, right, is going to be a numerical response variable. Okay. Let's see, hair color is a categorical explanatory variable. Okay. Categorical explanatory variables. Yeah. Say that again. Yeah. Yeah, so I am referring to this example here, or that one. Sorry, I'm still getting used to, I'm used to writing on the document cam, so then you can see where my finger is. I'll try to throw it up here more. Okay, so how about age? Age is kind of tricky, right? Let's do the quick test, right? Does it talk about, or does it make sense to talk about the average age? Yeah, right? So even though these ages, you don't typically report half an age, right? No one would say that they're 32 and a half, right? So whole numbers, even though it might be tempting to put them into categories, right? We're going to treat them as numerical variables, okay? So age is going to be a numerical explanatory variable. And then again, we have weight, I think, yeah. The weight is again a numerical explanatory variable. Yeah. So just a little note, explanatory variables. What the? Explanatory variables are collected in the hopes that they'll help explain changes in the response variable. Are collected in the hopes that they will help explain changes in the response variable. So that's the idea. Later on, and this isn't until at the very end of the term, we're going to start talking about regression, which is the relationship between two variables. Okay, so you've probably seen some sort of scatter plot. You have your x-axis, you have your y-axis. Okay. It's my husband, so it's fine, right? Should probably turn those up. Anyways, it's got hot in here. Oh. Lots of things happening. So the response variable, we would always plot it on the y-axis. And okay. He's gonna think this is so funny later. Yeah. So your response variable is gonna go on your y-axis, and your explanatory variable goes on the x-axis. And that's why I like to use response and explanatory, because explanatory goes on the x-axis. All for that. And if you're having a hard time keeping track of which is the x-axis and which is the y-axis, right? Because maybe you haven't done math in a while. I had someone tell me that she just imagined this little like cartoon X on the down here on the x-axis. And he's like, no, because it had fallen on him, and that's the x-axis. So whatever you got to do, okay. But that's the x-axis, and that is something that I do expect you to know. So the explanatory variable, you can only plot one at a time, right? But you can do them all individually. It goes on the x-axis, and then your response variable goes on the y-axis. Okay? And then we would end up with something fun like that. But that's a teaser for way later in the course. It's probably my favorite section too. Well, that's not true. Well, we've got some ties. Okay. Any questions so far? Okay. So, what do I need to talk about? Oh, there it is. Okay. So, just like we talked about here, right? We need to know what type of variable we have, right? Is it numerical? Is it categorical? Is it a response or an explanatory variable? Okay, because in our analyses, right, we'll need to know how we're supposed to treat these. So what we'll find is that now we're going to start talking about maybe numerical variables, and then we'll start talking about how do we deal with categorical variables, because we have to treat them differently, right? You've probably seen pie charts. More on those later, right? But it's just a circle with different slices of pie, and they represent categories, right? So what's important is if you're going to make a pie chart, you better make sure that you're actually making it of categorical variables, right? Not a numerical variable, because then you'll just get tons and tons of little slices, each for each data point, because very few of them are the same, right? So it wouldn't actually do anything, right? So that's what we're trying to help you out here, just so you don't produce something that, because all of it you will be able to make a pie chart of a numerical variable, it just doesn't make sense, right? And so the software will do whatever you want it to do, but at the end of the day, it's up to you to know what's reasonable and what's not. For example, calculating the average, sometimes it's possible, but you shouldn't, right? Because it doesn't make sense to talk about the average, right? Average hair color, for example, right? But we'll get into that maybe a little bit later. Okay. So all our analyses depend on whether we have a numerical or categorical variable. For example, shouldn't, right? You can, but you shouldn't calculate the average of a categorical variable. But sometimes you can, you just shouldn't. Any questions so far? No? So, a lot of terminology. Okay. But once we iron out all the details, then we'll kind of stick to our terminology, right? But it's good to have seen it all. Okay, so we'll parking lot that for a little bit, and we'll start talking about data collection. I'm not going to talk about it too much because it's pretty boring. And if you take like a surveys course or something like that, they should teach you about it. I'll always be giving you the data, right? So you don't have to worry about it too much, right? We're not going to collect our own data. That would be bad. But 1.3 is on data collection. Okay. And, oh, I just read that Google's developing a Google data search platform. So it's just data sets, and you can just search it for whatever data set you want. And so there's tons and tons and tons of data that's already been collected, and usually it's pretty usable, right? And so if you ever have to collect data, then it's probably already been collected and you don't have to spend money doing it, right? So data collection, a lot of data has already been collected and can be found online, of course. Oftentimes you can just get it for free. Canadian census data, you can just download. They anonymize it, of course. Can't have people's actual data in there, but anything that you might need to know about The BC population, for example, should be pretty reliable on there, even though census is gone, but whatever. Still pretty reliable, okay, all this information. So a lot of stuff is just, you can just find it online. Okay? On the off chance that you have to collect your own data at some point in your life, what I need you to remember is that it has to be randomly selected. Okay? So that at its very core, any data that you're using has to be randomly selected. Okay? So if you have to collect your own data, okay, you need to make sure your sample is randomly selected. Very important. Good question, but I'm gonna lock it in with a firm no. Yeah. Trying to think. Sort of, but we'll get there. I'll mention one brief instance where if you're trying to access or have representation of very remote parts of the community, for example, right, people that are hard to get information from, then you might have to go non-random, but that would be the only case. Okay. But we'll talk a little bit about that later. So what does it mean to be randomly selected? Random selection is when every individual in your population has the same probability of being selected. Okay, so randomly selected means that each individual in the population has the same probability of being selected into the sample. Okay. So there's lots of different ways that you can have random selection if you're dealing with a small population, like let's just say in this room, right? Then you can do something fun like I flip a coin, and if you get heads, then you're in the sample. If you get tails, you're not in the sample, right? Something like that. Usually you're dealing with way larger numbers. So if the college, for example, is trying to send out a survey to a random sample, okay, then often what they should do is they should just go through all the students at the college, right? Assign everyone a number. Okay, so everyone has a number, maybe their student number, right? And then you go to a random number generator. You can find one online. And I think random.org is the best one for closest to truly random. And then you get it to generate random numbers. And then you just pick whoever is in that random number generation that's on your list. They're in your sample, right? But like I said, I don't expect you to know how to develop a random sample. If that ever comes your way, you should have taken a course on sample selection, survey designs, that kind of thing. If you haven't, and you still have to collect a sample, you should probably hire someone to do it who knows what they're doing, because it's very important. Because unless you have a random sample, right, you can't actually assume that the sample is representative of your population. So you can calculate the average of your sample, but you can't actually say that, oh yeah, that's a pretty good estimate of what the population might be, right? Because your sample isn't a mirror of the population, right? So that's a pickle, okay? So what I need you to take out of this is we have to have random samples in order to do anything, right? Because in order for our sample to be representative of the population, our sample must be randomly selected. Our sample must be randomly selected. So that's the take-home message. If you're dealing with a sample, it has to be randomly selected because there's no other way to make sure that your sample represents the population, right? Which is what we need. Okay. Any questions? See you guys on Wednesday. Yeah. Oh, how many printouts should I bring next day? Who didn't get a printout? 1, 2, 3. Just 3? All right.